Hi class, this is Miss Lazarus. I just wanted to take a moment to go over how we can find measures of central tendency using a TI-84 calculator. For my first example here, I'm just going to briefly review how we do that by hand, and then I'm going to show you on the calculator how much faster it is to do it. So we have this data set here. It says to find the mean, median, and mode of our data set. We've got all these numbers here. And let's look first at the mean. So we know that mean is really short for the arithmetic mean, which just means that we're taking every value that we have here, adding them together, and then dividing by how many we have. And that's what you see right here in this formula. So we have x bar, which is the mean, is equal to, we have the sum, this is our little summation symbol, of every x value, and then we divide by n, which is the number of data points. So if we count these out, there's 20 of these data points here. When we go ahead and find the mean, we put our calculation in, we see that it's 10.7. So you have to add all that up and divide by 20, and we get 10.7. That's doing it by hand. And possibly just using a calculator, but still it's not the way that I'm going to show you how to do it, which is a more streamlined way that you can also get all your other central measures too. The next measure of center that we have is the median. Now, with the median, order does matter. So you actually have to put your data points in order. Notice here, we have 3 ones, okay? You see those as well up here. They're just out of order. We have 2 3s. You see those here, okay? And so on. So it's all the same data points, just put in order, and we're putting them in ascending order. We could put it in descending order and we'd still be able to find the median, which is the middle value. But typically we do that by putting it into ascending order. And then for the median, just remember that if there's an odd number of observations, like let's say that there were 21 data points, then it would just be the 11th data point would be the median, because that would be the number that's in the middle. But if we have an even number of data points, like right here we have 20, well then you actually have to average the 2 middle data points together to find the median. If you want to find what those 2 middle points are, as a review here, I just kind of wrote this out for you. And what I did was I wrote this kind of in a sequence notation. So a sub n is just the notation we use to mean, like, a sub n would be the nth term in our little sequence. So the first one would be a sub 1 would be 1, a sub 2 would be 1, a sub 3 would be 1, a sub 4 would be 3, a sub 5 would be 3, a sub 6 would be 4, a sub 7 would be 5, and so on. So this little subscript that you have here just means the order it is in the sequence. So for our formula to find one of the terms that we're going to average out, it's going to be a sub n over 2. In our case, n is 20. There's 20 data points. So it's a sub 20 over 2, which is a sub 10. So what we do is we go and look for the 10th term in our sequence. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our 10th term is 7. And so we go ahead and write that down. So a sub 10 is 7. And then we want to find the next term in the sequence so that we can average those. And the next term is always just going to be a sub n over 2 plus 1, which would be a sub, well, n was 20, so 20 over 2 is 10 plus 1, okay, which is a sub 11. So if we count over for our 11th term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, it actually happens to be 7 as well. So our median, another way that we write median is Q2, which just stands for the second quartile. Again, as a review, second quartile is just a location in our data set where 50% of the observations are below Q2 and 50% are above, aka the median, the middle. So Q2, our median, is equal to A sub n over 2 plus A sub n over 2 plus 1, which we just found these to be 7. So 7 plus 7, and then divided by 2. And then we just found these to be 7. So 7 plus 7 divided by 2, which is equal to 7. So that's the median. The other measure of central tendency that we use is the mode. Now, the mode is just the most frequent data point there is. And the way that we can find the mode is, again, if they're ordered, like we already have them ordered with the median, then you could just easily see like which one occurs most often. Well, notice that we have 3 1s. We also had 3 7s, and none of the other data points occur as frequently. So that mode value is actually shared by those 2 data points. In other words, we say that it's bimodal because we have 2 modes there. So 1 and 7 are our modes. Now let's look at how we do this in the calculator. So I'm going to go ahead and open up the calculator, and I'm going to put my data points in. So those are my data points up there. So I go to Stat, and I'm going to go to Edit. And I'm only working with one data set here, so it's just L1. To just go up and clear it out. Clear it out. Okay, so I have 7, 7, 1, 3, 18, 5, 12, 25, 24, 10, 5, 7, 28, 32, 4, 10, 1, 1, 3, 11. And so I've entered all those points in there. Notice that it's asking for the 21st point, but there are only 20 data points. So I know I've entered all 20. You can always just go and double check if you want to, the amounts. So once I'm done with that, so then I'm going to go ahead and quit out of there. I'm going to go back to Stat, and this time we're going to do Calculate. Now, we only had one data set here, so that's one variable. Or in other words, we're looking for X bar for this first one at least. We're summing all our X values together, so that's one variable. And then we're dividing by N, of course. And even with the median, it's X values here that we're using and the mode. So one variable. We're going to push Enter. Now, we're not using a frequency list right now, so let's go ahead and clear this out. We'll use that a little bit later. But notice here that our list that we were working with was list 1. Let me actually go back so you can see that real quick. So if I go to Stat, Edit, where we were working with list 1. If I had to put all my stuff in L2 or L3 or, one of these other ones, well, what I would have to do is I would go in, and when I'm doing my calculation for one variable statistics, let's say that it was L3, I would have to select L3 down here. You see where number 1 is, there's a little blue L1. Where number 2 is, there's a blue L2. Where number 3 is, a blue L3. 4, there's a blue L4, and so on. So if you want to get those, see how this blue button right here, the second button, it's a little shift button that lets you select all of the blue options for any key. So if I wanted L3, I would just hit second 3, and then I'll show you, and that would change to L3. But that's not what I want. I'm working with list 1. So I just do that, enter, enter, enter. And so this is what it gives me. Notice here, here's X bar, the mean, 10.7. Okay, so that's indeed what we have over here. Some of this other stuff we're going to find later, the standard deviation, but let's just look at the mean right now. And then notice it also tells us that n is 20. We knew that, but just in case, that's how many data points are. It also gives you other stuff like your minimum, your maximum. That'll be used later on when we find the range. We also have Q1, which is the first quartile. That just means it's a location in the distribution where 25% of the data points are below that point and 75 are above it. Here's the median. Notice they don't call it Q2 here, but I just, I wanted to review with you that we do call it Q2. But the median is 7. It also gives us Q3, which is the third quartile, where 75% of the data points are below that one and 25% are above it. So it gives us all of that. This is called a 5-number summary, but it's very, very, very useful. So notice when we put our list in, we didn't have to put it in order. And we still got that, we were still told that our median is 7, right? Because the calculator puts it in order for you. Now to find the mode, there's not as much of a straightforward way of doing it, except to allow the calculator to put your list in order like it does for the median, so it's easier to see which one comes up more frequently. So I'll show you how to do that. So you're going to go to Stat, and you're going to go to Sort. So we're going to go to Sort, which is number 2. And we want to sort out list 1, because that's where we put all our data. Okay, now when we go back to Stat and we go into Edit, notice list 1 is in order. And then you can easily count, see there's 3 1s here, there's 2 3s, 1 4, 2 5s, 3 7s, and you just keep doing that all the way down to see what occurs most frequently. And we know that 7 occurs 3 times, and so does 1. So this distribution is bimodal, and our 2 modes are 1 and 7. Now let's go over finding the weighted mean. So a weighted mean comes when we have data points that have different weights in the distribution. In other words, they count for different percentages. So for example here, a place that you see a weighted mean might be for your grade at the end of the semester. This is an example for a student. Let's say they got, these grades, their exam 1, 2, 3, and 4. These are their grades. The final exam, 92, homework 98, quizzes 83, and discussion boards 83. And according to the syllabus, these would be the percentages, and the student would know that ahead of time, right? So they do hold different weights. Each exam is 15% of the grade, while a final is 10%, homework is 20%, quizzes are 5%, and discussion boards are 5%. In the total column, you could either have it as a percentage, so 100%, or if we convert these from percentages, remember, percent means per 100, right? Per 100. So if I have 15%, let me just show you this real quick in case you need a review. If I have 15%, that means 15 per 100. Per, in math, per means to divide. So 15 per 100. Okay. which is just 15 divided by 100. And you plug that in, that's just 0.15. You plug that into your calculator if you want, or you could just do the division by hand. But that's where we're getting these in decimal form. The shortcut way is just to take your decimal and move it back twice, and that puts it right there, right? So you might have learned that shortcut before. But yeah. So you'll see all these percentages converted to decimal form, and when you add up the decimals, they should add up to 1, or you did something wrong. Now, the formula for the weighted mean, you're trying to find the mean when these all have like different weights. Well, it's going to be the sum of all of your x values times their weights. So the sum of all your x values times their weights. And then divided by the sum of the weights. And so for this particular example, when we go to find that weighted mean, the first x value is the grade of 85, and its weight is 0.15. We add that to the second one, 93, times its weight of 0.15. The third one, 96, times its weight of 0.15. And so on all the way down to the last grade of 83 times its weight of 0.05. And then we divide that by the total weight, which was, in this case, just added up to 1, but that's not always the case. And when we do that, we get 89.75 approximately. And that's our weighted mean. Now, let me show you how to do this in the calculator. I'm going to go ahead and use list 2, and that's just because in another video to follow, I'm going to go over measures of variation, and we're going to use this same data set that we have here. So let me just keep all that in list 1. All right, list 2, we're going to go ahead and put in our grades. So 85, 93, 96, 77, 92, 98, 83, and 83. And then 0.15 is the weight for the first one. Second exam is also 0.15. Third exam is also 0.15. Fourth one is 0.15. The final is worth 0.1. Homework is worth 0.2. Quizzes are 0.05. And discussion boards are 0.05. And then what I'm going to do is I'm going to go to, notice that our x values are in L2 and our weights are in L3. Now I'm going to go to stat. I'm going to go to calculate. One variable statistics again, because we're just using x. Okay, my x values now are in list 2, the ones we're concerned with. The frequency list is where you'll put those weights. So that was in L3. And we push enter. And notice that we have that mean value of 89.75. And it actually comes out to exactly 89.75. So I'm going to change that real fast. Earlier I had the approximation symbol, but that wasn't an approximation. It's exactly 89.75. Now let's look at finding the mean of group data. In this example, we're asked to find the mean of the following data set of the number of hours of sleep a class of students gets per night. So notice that our variable of interest is x. We see that in the left column, the number of hours the students are getting of sleep a night. And then in the right column is the frequency, like how many students get that many hours of sleep. So 0 hours of sleep is 1 student. 1 hour of sleep is 0 students. 2 hours of sleep is 1 student. 3 hours of sleep, 2 students. 4 hours of sleep, 3 students. 5 hours of sleep, 5 students get. 6 hours of sleep, 7 students. 7 hours of sleep, 7 students. And then 8 hours of sleep, there's 8 students that get that. Now the formula, if we do this by hand, is that x bar is equal to the sum of every x value times its frequency divided by the sum of the frequencies, which is actually n. So that's how many students you have, right? That's how many students you have, n. At least for this example. But n would just be the number of just the total of the frequency. So here are our frequencies totaled up. So there's 34 students then, right? 34. If you add all this up, there's 34. 34 students. And then what we do is we take each of those hours of sleep and we multiply by the frequency, how often that happens. So 0 times 1 is 0. 1 times 0 is 0. 2 times 1 is 2. 3 times 2 is 6. 4 times 3 is 12. All the way down to 8 times 8 is 64. And so those are each of the observations, in this case hours, times their frequency. We add all that up and we get the sum of the x values times their frequencies is 200. And putting it into the formula for the mean for group data, we end up with 200, right, the sum of the x values times the frequency, divided by the sum of the frequencies. In other words, the number of students for our example, which is 34. 200 divided by 34 is approximately, that's what the squiggly equal sign is, approximately 5.882. So that's the mean hours of sleep that the students are getting per night. Now let's see how that looks in the calculator. So I'm going to go into edit, and that last example, I believe I'm also going to use in my next video for measures of spread. So this set of data values I'm going to put in L4 and then their frequencies in L5. So we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then we're going to do the frequencies. So 0 hours of sleep was 1 student. 1 hour of sleep was 0 students. 2 hours of sleep was 1. 3 hours of sleep was 2. 4 hours of sleep was 3. 5 hours is 5. 6 hours is 7. 7 hours is 7. And then 8 hours is 8. So that notice again, that's list 4 for the X hours of sleep, list 5 for their frequencies. Now I'm going to go to stat and I'm going to go to calc, one variable statistics, but this is list 4 and list 5 now. So I'm going to change this to list 4 and I'm going to change this one to list 5. I'm going to do enter, and notice here my mean, my X bar, my mean is approximately 5.882, and that's what we have right here. So doing it by hand, we had to multiply each of our X values by their frequency, and I made a little table to help organize it to get that 200. To get N, which was the sum of the frequencies, I had to add all that together to get 34. To take the 200, divide by 34 to get this approximately 5.882. But it was much faster just to enter this information into the table in the calculator, and then it spits out all of this for me. And it even gives me all, other values too that we're going to use for measures of spread and so on. It even gives us the median, even though it's not asked for that in this question. The median is 6. So if I wanted to, I could go through and write out 34 data points, right? There would be 8 of them that were 8. There'd be 7 of them that are 7, 7 of them that are 6, and 5 of them that are 5, 3 of them that are 4, 2 of them that are 3, 1 of them that's 2. We wouldn't have any ones written down because there's a 0 frequency there, and there'd be 1, 0. So all of that would be written out, and the median would just be the middle value, which would come out to be 6. If we wanted to find the mode, well, that's really easy to look at here. Just notice the highest frequency is 8. Right, so the mode is 8. But again, here we're just asked to find the mean. Now let's look at estimating the mean of group data. Now here we're making an estimate because we don't know specifically what those data values are. We have classes and we're able to say how many fall in a certain class. So for this one, I don't have a particular example. I'm just showing you. Let's say we have a class of 1 to 11. So data points that are in the group of 1 to 11. And then we have some that are 12 to 22, 23 to 33, and so on, all the way up to 89 to 99. What you do if you want to find the mean of this frequency distribution, first of all, you need to find the class midpoint. The midpoint is found by taking the lower class limit and adding it to the upper class limit. So in this case, 1 plus 11, and dividing by 2. If I do 1 plus 11 divided by 2, I get 6. So that's my first class midpoint. The second one would be 12 plus 22, which is 34, divided by 2 is 17. So that's how we get all these numbers here. And then the frequency is how many numbers fall in each of those classes. So we don't know what those are. For this class, it could have been the number 1 and the number 8. Not even what the midpoint is, just the number 1 and number 8, but that's a frequency of 2. There weren't any numbers from 12 to 22 inclusive of those endpoints, so that's why that's a frequency of 0. But that's where that's coming from. And then what we'll do is we have a formula similar to the formula for the mean of group data that we saw previously, except for the x values. They're not actually the x values, they're the midpoints of each class. So x bar is going to be equal to the sum of each class midpoint times the frequency of the data points within that class. So what I did was, if I'm doing it by hand, I made a little table. So a class midpoint of 6 times the frequency. There were 2 that were in that class of 1 to 11. 6 times 2 is 12. 17 times 0 is 0. 28, that's the class midpoint of this third class right here. There's 2 data values in that class. A frequency of 2. 2 times 28 is 56. And so we do that all the way down. And when we get the sum of each of those midpoints times the frequency of the class for that midpoint, it comes out to 2,471. So that's what goes here on top. And then the sum of the frequencies, that's n. Well, that equals 36. So that's how many data points you have. And then if I take 2471 divided by 36, I get 68.638. And that 8 with a bar on top just means 8888. It just keeps on going as a repeated decimal there. So now let's look at how to do that with the calculator. So let's see. I guess I'm going to have to erase some of this because I need to use list 5 and list 6. I don't have any more lists. But what I'm going to do is put the class midpoints in list 5. Okay. And then I'm going to put the frequency for each class So 2, 0, 2, 1, 2, 6, 8, 8, and 7. Then I'm going to go, notice again, this is L5 and L6 where we put our information. Go to Stat, Calc, One Variable Statistics, and it was List 5 and List 6. So List 5 and List 6. And calculate it. So here it is. So X bar, our mean is 68.638 with a little bar on top. Or you could round it to 0.639 if you want to do that, round up on it. But this is fine right here. Okay, so that's all for that one. And I believe that actually brings us to the end of our video. Thank you for watching, and I'll see you in the next video where we go over how to find measures of spread using the TI-84 calculator. I'll see you then.